Okay, metabolism, guys, based on the definition that I like to give you, metabolism is, what is the definition of metabolism? Anybody? I think I gave it to you at the beginning of semester. If not, metabolism is catabolism and anabolism. That's what metabolism is. I'm going to write it here because for the rest of the period, metabolism is A, anabolism, building up, and B, catabolism. So anabolism means building up, and catabolism means what? Breaking down. That's what pretty much what metabolism is. Okay, so an organism's metabolism transfers matters and energy subject to laws of thermodynamics. And laws of thermodynamics is something else I need to talk about it as well. What is catabolism? I already said that. Catabolism, it means breaking down, and what is anabolism? It means building up. And the definition of metabolism, it means constantly, your body, even at night when you sleep, it's breaking down and building up. Breaking down molecules and building up molecules. That's what metabolism is. Until our death. When we die, then there is nothing. Okay, so bioenergetics, that's another definition I would like you to know, is the study of how energy flows through living organisms. That's bioenergetics, which refers, that's this bioenergetics, pretty much this will explain the laws of thermodynamics. So bioenergetics, how energy flows into us, how energy flows into plants, and so on and so forth. So here is metabolic pathway, breaking down and building up. So you have compound A, starting molecule, reaction with enzymes, of course, become B. Again, B becomes C by enzyme 2, C becomes D, that would be the end product. Okay, so, and in between you always have enzymes, okay? You always have enzymes. Here is a diver has more potential energy. There are different type of energy. This one has more kinetic energy, and a diver has less potential energy in water and is climbing up. Eventually, when he climbs up and go up here, then he is loaded with energy, and that energy is going to be spent going into the water. So I hope you understand the cycle of the energy. Of course, this will happen in a cell. This is a cycle of energy, kinetic energy, potential energy, potential energy to kinetic energy, and kinetic energy comes and loads itself up again to potential energy. And that's what happens inside of a cell. When you ate glucose this morning, that glucose inside of your body is full of potential energy. And right now you're spending it by swinging your legs, you're taking notes, you're thinking, and then all of that potential energy is becoming kinetic energy. I hope I'm making some sense. But anyway. What are the laws of thermodynamics? The laws of energy of transformation. The thermodynamics is the study of energy transformation. According to the first law of thermodynamics, the energy of the universe is constant. So if I have a gallon, some liter of gasoline in here, that gasoline here will remain constant for eternity. The gasoline in here will stay here forever and ever and ever. Nothing will happen to that liter of gasoline. That is portion of the first law of thermodynamics. It's constant. Energy can be transferred and transformed, but it cannot be created or destroyed. So what am I saying? That the gasoline in here, it cannot be converted to another energy, and nothing will happen to this gasoline. It's always remain that energy that is in here. That's the first law of thermodynamics. Energy cannot be created nor can be destroyed. This will not become anything else. This gasoline will not become sugar water. Put it this way. this gasoline will not become water. It cannot become anything else. Okay? So that's what the first law of thermodynamics is. Energy cannot be destroyed and cannot be created. The amount of energy is constant. Okay? Then the first law of thermodynamics is called the principles of conservation of energy. What is second law of first law of thermodynamics? According to the first law of thermodynamics, energy in the universe is constant. Energy can be transferred. Yes, I'm repeating myself again. Sorry about that. The second law. Here we go. I don't know what happened. Steven sabotaged my PowerPoints. He hacked into my. You all know what Apple is? An FBI. FBI is telling Apple, let us use that cell phone. And Apple saying no. I guess they asked Steven. Steven can hack. Fix it. I have 2 PowerPoints of same things. Okay, second law of thermodynamics says during every energy transfer or transformation, some energy is unstable and is often lost as heat. According to the second law of thermodynamics, energy transformation increase entropy or disorder. So, what is second law of thermodynamics? Second law of thermodynamics saying this is gasoline, right? This gasoline goes inside of a motorbike, right? You all know what I'm talking about. So when this goes inside of the motorbike and the motorbike is going cruising on the road, so you transform, the second law, I'm talking about the second law of thermodynamics. You transform that energy that is inside of this gasoline, you transform it into motion, right? So you're moving, it transforms it to mechanical energy. That motor is working with mechanics. Am I making some sense? And also, in between, when you transform this energy to motion energy and mechanical energy, something in between is also lost. That something that is in between is lost. They call it entropy. So nothing, when you transform this energy to the mechanical energy, the motion energy, all of that, it's not 100% efficient. Never ever, so far. Nothing is 100% efficient. It means if there is 100 units of energy in here, that 100 units of energy is translated to motion and mechanical energy as 30 units. In between, you lost 70 units of energy. Am I making some sense, everybody? So, and that lost unit is called entropy. Entropy, or we call it disorder. So anytime you take energy and you convert it to another form of energy, this morning, let's go another example, forget the gasoline. This morning you had pancake, right? It's full of potential energy. Now you're transforming it as taking notes, swinging your legs, am I right? Scratching your head. Those are all energies you're spending. You're thinking, right? You're taking notes. Today, pretty soon, you're going to take a quiz, so you're thinking. You're converting that mashed potato you had for breakfast, right? Lauren, the mashed potato you had for breakfast, you're converting it into chemical energy. However, in between, you're wasting some of that energy. That waste is called entropy. And that waste usually is showing up in you as heat. Entropy translates into heat. Okay, let's see what else. Here we go. A bear goes catch a fish. Okay, that's the first law of thermodynamics. That energy in here in the fish is constant. It does not change. But when that bear is going and running, he's making that chemical energy in here in the fish into running. Am I making some sense, everybody? And then also, while he's running and he's converting that energy to motion energy, he is losing some energy. And that energy, that entropy, is usually heat. Hope I'm making some sense. That's That is bioenergetics. Do you remember that? I'm not going to go back. That's called bioenergetics. The flow of energy into the bear, and bear spending the energy. First law of thermodynamic, second law of thermodynamic. I gave you several examples. I gave you example of gasoline. I gave you sugar moly, mashed potato in the breakfast. I gave you this is a third example. I gave you a bear eating a fish. I gave you 3 examples of first law of thermodynamic and second law of thermodynamic. Okay, let's see what this. What is exergonic and endergonic reactions in metabolism? Exergonic reaction proceeds with a net release of free energy, and it is spontaneous. So exergonic reaction is like your cellular respiration. The sugar you ate this morning, am I making some sense? Or the bear had the fish. All of that fish, all of that sugar molecule is breaking down. Right here. Breaking down. When you break down, what happens? It's an exergonic reaction. Proceeds with the release of free energy. When this breaks, gives you free energy. Okay? Then endergonic reaction is opposite of exergonic reaction. Endergonic reaction is when you're putting it together. It absorbs free energy as surrounding and is non-spontaneous. Photosynthesis is an example of endergonic reaction. When photosynthesis is happening right now, it's the springtime, beginning of springtime a little bit, but a lot of photosynthesis. You see all of the flowers are blooming. You seen that? All of the blossoms are around. Have you seen that? That is endergonic reaction. Photosynthesis is a good example of endergonic reaction. Okay, I hope I'm making some sense. And then living systems, free energy is energy that can do work when temperature and pressure are uniform, as in living cells. Cells are not in equilibrium. No, cells are not in equilibrium. Constantly is up and down. Inside of the cell is up and down. Okay, but the open system, cells are open system, experiencing a constant flow of materials. Defining features of life is that metabolism is never at equilibrium. Okay, metabolism. You all know what metabolism means. Somebody grab your collar in the mall and say, what is metabolism? You tell them metabolism is catabolism and anabolism. Oh, right? Catabolism, anabolism. That's what you tell them. If somebody grabs your collar, some of you do not have collar, go out with some collar, like me. I do not have this one. No, Reno would be a good candidate for grabbing his collar. He has a lot of collar. Okay, ATP powers cellular work by coupling exergonic reactions to endergonic reactions. So I hope you start understanding these things. A cell does 3 main kind of work: chemical, transport, and mechanical. And I think during my talk so far, I went over all of these. This is something that you and I need to focus a little bit. These 2, we already talked about this a little bit. And then the mechanical one, not too much. We were not going to talk about it too much. Maybe you take physiology or go to zoology. The first 2 weeks in zoology, they will talk about a little bit of mechanical. But the rest of what you are going to spend your career as a student is going to be these 2. And a lot of it that one. 90% that one. I say 9% that one, and maybe 1% that one. Okay, ATP, coming back to ATP again, adenosine triphosphate is the cell's energy shuttle. ATP is composed of ribose, sugar molecule, adenine, nitrogenous base, and 3-phosphate. You already know that, like back of your hand. Okay, here it is, ATP. We talked about it, and in presence of water it becomes ADP, 1-phosphate release, and when it becomes ATP, ADP, when ATP becomes ADP, allows you to walk. Is that right? Allows you to move your hand. Right now I'm converting ATP to ADP. If I did not have any ATP inside of my body, I would be dead. People who die They become rigor mortis. Have you heard of rigor mortis? They become stiff. Have you know what I'm talking about? People who die, they become very stiff because there is no ATP inside of their body. All of ATP vanish. Okay, I hope I'm making some sense. Over here, look at this. Look at this one. Are you seeing this? ATP becomes ADP plus a cloud of, what is this? Anybody can read that? I cannot read it from here. I'm too close. Huh? Energy. Oh, thank God. Hallelujah. Praise the Lord. We got it. Energy. If it wasn't because of Lauren, we had to wait until tomorrow morning somebody say that. That's what I got. And Lauren, she sits way in the back. Okay, right here, right here. What are some of the functions of ATP? Oh, there is a big long list, but how many he mentioned here? 4 of them, that's fine. ATP drives endoganic reactions by phosphorylation, transferring a phosphate. Yes, that term phosphorylation coming to you again. Transferring a phosphate group to some other molecules such as reactants. The recipient molecule is now called phosphorylated intermediate. Yes, the transport and mechanical work in the cells are also powered by ATP hydrolysis. Hydrolysis, you all know what that means from beginning of semester, right here in January. ATP hydrolysis leads to change in protein shape and binding ability. The list goes on and on. He gives you just those 3 or 4. Here is a mechanical move. ATP causes the vesicles in the cell to move on a microtubules. Right here is the microtubules, and these are the motor protein molecules allows you. Again, ATP, we already studied this, attached to the cell receptors and cause the ion channels open up so the molecules come inside of the cell or outside of the cell. You already know that. You already know the functions of ATP on this chapter. ATP again becomes ADP with help of water, hydrolysis, and gives you energy. Okay, what are enzymes and their functions? Let's move to enzymes, something that so far in this class we have not talked about it too much. I just briefly say ACE at the end of the word. I erased it. ASE at the end of the word, it means enzyme. Anybody grabs your collar in the mall, says, what is ACE? Say, I'm an ACE. Brian, have you ever called ACE? Any of your friends? Like on the playing cards, you have ACE. ACE is a top card. It's a top dog. You don't play cards?
I do, but no one ever called me ACE.
But nobody called you ACE. Well, Brian, you're being humble. I'm sure somebody didn't call you ACE. During my college years, they called me ACE. Some friends, you know. Oh, of course, other people called me a-hole. I don't say that. So I get combination of both. ACE and a-hole. I don't know I'm allowed to say that on YouTube. But that's what I'm saying. But anyhow, so ACE at the end of the word means enzyme, ASE. Anytime you hear that, pancreas is not E at the end. The pancreas is not spelled, you all know what pancreas is. The way they spell I always have to say this, the way it's pancreas, that's it. There's no E at the end. But if I say lipase, it means an enzyme that breaks down fat, lipid. You already know lipid, fat means lipase. Protease, what does that mean? What do you think it is? Huh? It breaks down what? Proteins. Protease breaks down protein molecules. Okay, so anyhow, enzymes speed up metabolic reaction by lowering energy barriers. I will talk about that, show you at the beginning, but let's talk about it here. If I have this amount of water and I want to dissolve sugar in it, what are different ways? I think I asked you that last time. What are different ways I can speed up the dissolvement of sugar in here? Heat it? Stir it? How about if I don't want to heat it up? I don't want to stir it. I have to pay PG&E too much. Imagine the Coke company, Coca-Cola and Pepsi, they have tanks as big as this room full of water, and they want to dissolve all that sugar. You know, every time you drink a can of Coke, there's 12 spoons of sugar in there. 12. Read it up. I'm not making it up. I'm on YouTube. I cannot make up things.
Is that bad for you?
I don't know. It's bad for you or not. I don't know.
Your body needs sugar.
Not 12 tablespoons of
At
it
once.
at once in a little container. So what they do, the Coke company and all those companies, they do not want to pay PG&E. You all know what PG&E is. They have to stir it up, right, or heat it up in order to get all that sugar dissolved in the water. So what they do, they add enzymes to get that sugar mixed up. Of course, they have to stir up a little bit or heat up a little bit, but with help of enzymes, they bring their PG&E cost lower.
Where do the enzymes go?
Nothing. The enzymes, they filter it later on. They filter it later on. Okay. So a catalyst is a generic term for enzyme. It's a chemical agent that speed up a reaction without being consumed by the reaction. In chemistry classes you took, you probably came across the term catalyst. A catalyst is something that converts molecule A to molecule B, and C still is a C. C is a C. So this is a catalyst. A catalyst turns molecule A to molecule B. It does not change at the end. Okay. An enzyme is a catalytic protein. Enzyme is a protein molecule. Okay. Later on during semester, you learn one enzyme which is not a protein; it's an RNA. But for now, most all enzymes are protein, not the other way around. Not all proteins are enzymes. No, all enzymes are protein. Okay. Hydrolysis of sucrose by the enzyme sucrase is example of enzyme catalyzed reaction. So I use this example a lot for the rest of semester. I hope you all know what I'm talking about. Can anybody refresh my memory from exam number 1? Some of you, I guess, studying for it. I don't know. I'm not with you 24/7. Okay, so sucrose is what? Made up of what? Sucrose is made up of what? Glucose and what? And fructose. Sucrose in the presence of what enzyme becomes glucose and fructose? Sucrase. Sucrose in the presence of enzyme sucrase becomes glucose and fructose. No, what they call this as sucrose, a generic term, they call it substrate. Substrate is anything that enzyme act upon. That's a substrate. And of course, sucrase is what? An enzyme, which is a protein molecule. And what are these two guys? What are these two musketeers? Product. So, hydrolysis of sucrase, I gave you that picture right there. Here it is, sucrase, sucrose, I'm sorry. You know this, plus water, of course, you need water molecule. In presence of sucrase becomes glucose and fructose. We already discussed this at the beginning of semester. Here, when I said lower activation energy, this is what I mean. What happens in case of enzymes when you want to convert molecules to each other? At the beginning, it lowers, he gave you delta G, and I did not talk about delta G as much in here, but just the example I gave you, like a Coke company, or when you want to mix up sugar in water, what enzymes do, enzymes lower your heating cost, okay, the heating cost. You want to heat it, you want to stir it. That's what help of enzymes, and that's what this chart is showing you. Here, here we go. Well, okay, here is a reaction taking place without enzymes. This is much energy you have to spend. This is in case you add enzymes and you spend less energy. You still have to spend some energy. You still have to spend some energy, but it's not as much. I hope this diagram makes sense. Okay. What is a substrate? I already talked about that. A substrate reactant that enzyme act on it is called enzyme substrate. Enzymes binds to substrate, forming an enzyme substrate complex. So the enzyme and substrate, they are like a lock and key. A lot of places you have a key, you have a lock. When they go together, they call it lock and key. So they call it enzyme substrate complex. The analogy I'm making is like a lock and key. Okay. The reaction catalyzed by each enzyme is very specific. The enzyme sucrase cannot break down, very specific. It cannot break down maltose. It cannot break down lactose. The enzyme for lactose is what? Some of you are intolerant. Lactase. So that enzyme is different than that enzyme, and the enzyme that breaks down maltose is what? Maltase. They are very specific. Enzymes are very specific. You all have keys in this room. Is anybody who does not have a key in this room? Huh? Key? I'm talking about key. You all have key. Katrina, you have key. Mendoza, you have key. Can any of your key open up this door? No. I have a lot of keys. Guess how many of them can open up this door? Only one of them. Only one of them. Same thing. Enzymes are very specific. They're very, very specific. I gave you examples. I gave you analogy. Okay, the active site is the region on the enzyme where the substrate binds and the chemical reaction occurs. So let's see some pictures. Here is enzyme. Enzymes are made up of what? Enzymes are made up of protein. Proteins are made up of what? Amino acids. So all of these little balls you see in here, they're all amino acids. And then where the chemical reaction occurs is called active site. So that substrate, it comes right into active site, and then of course it causes the chemical reaction to occur. If that substrate goes sits here, it will not occur. If that substrate goes sit here, the chemical reaction will not occur. So enzyme is a protein molecule, is a large protein, it's a huge, it's a kind of protein, it's a big protein molecule, and the enzyme goes where at a specific site. They call that active site. That specific site is where the chemical reaction occurs. Okay, I hope I'm making some sense. Video closure of hexokinase via induced fit. Oh, hey. They're showing you that. Okay, so substrate interactive site. Okay, substrate are held in active site by weak interactions, and right here substrate to convert products. The shape of the protein molecules change. Okay, and then products are formed, and then finally the enzyme goes to its original shape. The shape of the enzyme is different than this shape. This shape is different than that shape. Okay. But again, the enzyme at the end is same. Nothing happened to that enzyme. None of the amino acids got separated from it when you have the products. None of the amino acids get separated from or phosphate or sucre or sulfur or anything. Nothing happens to sucrase. Okay, what are the effects of local conditions on enzymes? Enzyme activity can be affected by general environmental factors such as pH, temperature. Of course, when when I add a strong pH to an enzyme and the shape of the enzyme change, what did I do to that enzyme? Anybody remembers the notes from beginning material? What happens if I put heat or pH on the enzyme? What will happen to the enzyme? Huh? The enzyme shape changes for good forever when I add strong acid to an enzyme, or if I heat it up very much, very high heat. What will happen? The shape of enzyme change, and what did I do to that enzyme? I denatured it. Is that right? Denaturation. Denaturation, it means when you change the shape of the enzyme, the shape of protein or molecule, anytime you denature it. We talked about denaturation. So a chemical that specifically influence the enzyme, optimal condition favor the most active shape for enzymes. Here we go. Here is an optimal temperature for the enzymes that is working inside of us, right here, 37. Here is the temperature for some bacteria enzymes. Bacteria that live in hot springs of Yellowstone National Park. Have you been in Yellowstone National Park? They have hot springs, and there are bacteria there. You and I go into those hot springs, we will die right away, we burn to death. But there are bacteria there. There are living organisms in there. So, don't they have enzymes? Yes, they do. They have enzymes. Their enzymes are active at 77 Celsius. You and I are active at 37 Celsius. They take our enzymes and put it in 77 Celsius, they all denature. They take their enzymes, 77 Celsius, and they put it in our body temperature, they all denature. Am I making some sense a little bit, everybody? Same as pH. Same as pH. The optimal pH for the enzymes in your stomach is 2 point. Very strong acid. The pH of your stomach is about 2. They take that enzymes and put it in your brain, they will not work. Those enzymes will denature. And they take the enzymes from your brain and put it in your stomach, they will denature. They will, the shape changes. The shape changes. I hope I'm making some sense. Everybody, so enzymes have to work on optimum pH. The enzymes in your stomach, tyrosine, pepsin. Pepsin is an enzyme that works in your stomach, breaks down protein molecule. And then of course, the enzyme in your body, anywhere, sucrase, lactase. They are pH of 7.5, 7.6. He says 8. I kind of disagree with him. But anyway, same as temperatures. No enzymes in our body works at cold temperature. That's why I say fever is not good. If somebody has fever of 40 degrees, the enzymes will become denatured. 40 Celsius, it translates to 104, 105 Fahrenheit. You don't want to have a fever. One thing you have to deal with it. A lot of things happen, but one thing you have to deal with is the denatured enzymes. You lose your enzymes of your body, and that's not healthy. Okay, cofactors. Let's finish up these days. Not much. Cofactors are non-protein enzymes. I will give you a set of questions for these enzyme section, but that's not going to be homework because I answered them. I will give you a new set for homework. So just read my email for Wednesday. I'm going to send you an email for what are your homework questions. Okay, but anyhow. Okay, cofactors are non-protein enzymes helpers. They are enzymes helpers. Some of you are not in the habit of reading a sentence completely. I say, oh, cofactors are not enzymes. Yeah, non-protein enzymes, but they help enzymes. Just like copilots. You know copilots, right? Copilots help the pilots to crash the airplane, right? Is that right? That's what they are. So but these guys will help the cofactors. Cofactors may be inorganic, such as, you already know what inorganic means, such as metals and ions and on and on. An organic cofactor is called coenzymes. Coenzymes include vitamins and other goodies. Okay, let's stop right here. This is the end of the material. Let's take a 5 minutes break again, and then when you come back, we'll do the lab. For this lab, again,